In the name of Allah, the most gracious, the most merciful, here we have to deal today with our new program online using Tabarak website, Tabarak school website with you, teacher Muhammad al-Badri, grade 9 mathematics teachers here, and we are going to start with unit 3, the circle unit, and today we are going to deal with the lesson of the inscribed angle. And we have to say thank you for the chairman, Mr. Yunus al-Rahabi, who allows to us to use the website of the school to explain our new lessons.
How are you, my dear students? Today we are going to study new lessons about the relationship between the inscribed angle and the central angle. Okay. For the first one here, we have to know the difference between the inscribed angle and the central angle. Here we have a circle, and if we see this circle, we can see that here we have an arc, okay, intercepted arc, and we have here two chords. These two chords, we have to know that these chords, between them an angle, this angle, have a vertex on the circle. So the inscribed angle, an angle whose vertex is on a circle, not inside the circle, it must be on the circle, and each side of the two sides of the angle must be a chord. Now we have the second paper here named the intercepted arc for the angle. Here we have an angle. This angle is CTL. So how could we know the intercepted arc? Here the intercepted arc is the opposite to the vertex of the angle. Here we have three letters C, T and L. These three letters, we have a vertex. Very important, we have to know where is the vertex. The vertex is the middle letter. The vertex is the letter between the two sides. So here we have two sides. The first side is the chord C, T, and the second is the chord TL. So we will notice that the T here is common between the first side TC and the second side TL. So now we can say the angle is CTL, and this angle is intercepted angle. So inscribed angle. So where is the arc? Here the arc is CL, the opposite to the vertex T. Here we know the arc, and we have the arc, we can write it CL or LC, and the sign of the arc is very important to know it. The arc is something like curved line above the two letters. Now here we have a relationship between two inscribed angles. How could we know the relationship between two inscribed angles? Here they must have the same arc. How could we know that these two angles have the same arc? Like the figure which we have it now, we have a figure, and inside this figure we have two angles. One of them is blue and the other one is red, and we can notice that the beginning points for the two angles are the same beginning points. So these 2 points which have 72 degrees are the arc, which are these two angles are subtended on the arc 72 degrees. So we have a new theorem for this one. If two inscribed angles intercepted the same arc, they are congruent, or we can say they are similar, or we can say then they have the same measure or equal. Therefore we can say that here we have a blue angle again, and we have a red angle. These two angles are the same angles. Why same angles? Because here we have the same starting point between the first and the second angle, so they must have the same measure unit. And now we are going to the next page here. How could we find the measure of the inscribed angle? We have to know the type of the inscribed angle. How could we know it? We said it before. I hear someone say it to me, teacher. We have the inscribed angle. If the angle has a vertex on the circle, yeah, you are an excellent student. So here, if we need to find the measure of it, we can say that the inscribed angle, we have it here. The inscribed angle equals what? Equal intercepted arc over 2. So we have here in the figure what is the measure of the arc? Here we have it 160 degree. So we can say here the inscribed angle, the same measure. Can we say it 160? No, we cannot say it 160. Why? Because it is a half of 160. So the half of 160 is 80 degrees. So now here we are going to the next page here, an example. This example say that here if measure of the arc JK is 80 degrees. Find the measure of the angle JMK. How could we find it? We have to know the type of the angle. Do we have here an inscribed angle? Yeah, I hear someone say, yeah, we have it. Yes, you are an excellent student. Yes, we have it. Why? Someone say to me, teacher, we have a vertex on the circle. You too, an excellent student. Yeah, we have the vertex. And the two sides are what? Who can say it to me now? Yeah, we have the two sides are chords. So now here we have a measure of angle JMK equals what? Equals what? Can we say it 80? Can we say it 160? No, we cannot say 160. Neither we can say it here 80 degree. Why? Yeah, very good. Here we have the angle JMK is inscribed angle. And the arc JK is what? Is 80 degrees. So the measure of the inscribed angle is what? Yes, very good. Half of the arc. So it becomes 80 divided by 2 equals 40 degrees. Thank you very much. Now we are going to the next example here. Number 4, we have if the measure of angle MKS. MKS here we have an inscribed angle. Yeah, we have an inscribed angle. The same conditions of the number 3. So here we have the angle MKS equals 56. Yeah, we have an angle equal 56, not we have an arc equal 56. Before we divided by 2, but now we have the opposite, so we have to who can say it? Yes, it's multiplied by 2. So the measure of the angle MKS equals 56 degrees. So now here's the measure of the arc MS, which he needed is, can I say it 56 divided by 2? Yes, excellent. We cannot say it. Why? Because we need to find the arc equals 56 multiplied by 2. So now here, if he is giving me the measure of the arc and he needs the measure of the angle, we are divided by 2. And the opposite of it, if he is giving me the measure of the angle and he needs the measure of the arc, so we have to multiply by 2. This is very important. You have to focus in these points. Very important. How could we find the measure of the arc and how could we find the measure of the angle? Thank you. And we are going now to the next page here, the relationship between the central angle and the circumference angle, or the inscribed angle. So now here we have what do we call the type of the angle. Here in this figure we have two angles. One of them is X and the other one is Y. So can we say here we have the same angles? No. Why no? I hear someone here, he's saying to me, teacher, we have different angles. We don't have both of them the same inscribed angles. Yes, you are an excellent student, because here we have an inscribed angle, which is Y, and we have a central angle X. Yes, so here we have two different angles. So how could we find the relationship between them now? It's very easy. We can find it here in the rectangle. The measure of the inscribed angle is what? Half of the measure of the inscribed arc. So here we have an inscribed angle and an inscribed arc. Yeah. So how could we know the measure of the angle X? Teacher, I am confused. No, don't confuse, because here is the same for what we studied before, but x is a central angle. We can say here x is a central angle and y is an inscribed angle. So when we are going to say about x is half of y or double of y, here you can guess it. You have 2 seconds to guess it. Yes, I hear someone saying to me that x is double of y. You are an excellent student. Why? Because here we have an x is a central angle and y is an inscribed angle. So x equals double of y and y equals 120 divided by 2 equals 60, like what we did it before. So here y equals what? Y equals angle y equals 120 divided by 2 and x equals 120. So now here's the relationship between the inscribed angle and the central angle. The relationship between y and x is y equals half x and x equals, who can say it? 2. Measure of y. Yes, very important. Yeah. Now, if we need to say it again here, what is the relationship between the central angle and the inscribed angle? The relationship between them are x equals double y or y equals half x. It's very good. Thank you. It's very excellent students. You are very excellent students. So now here the measure of the inscribed angle is half of the measure of the inscribed arc that we are going to say here for an example. What do we solve for? How do we solve for y? What is the value of x? So now here we have an arc equals 120. So x equals what? You have now 2 choices. X equals 120 or x equals 60. Who can say it now? Yes, x equals 120 and y equals what? 120 divided by what? Yes, divided by 2. Yeah, no. So now here x equals what? X equals 120 and y equals 60. Thank you. For the next page here, example 5 here in circle J, measure of angle 3 equals 5x and measure of angle 4 equals 2x plus 9. Find the value of x. So now here, what is the relationship between 3 and 4? Do 3 like 4, inscribed and inscribed? Yes, we have 3 the vertex on the circle and angle 4 the vertex on the circle, u. So now here we have to inscribe the angle. This is the first thing. The second thing here, do you have the same RQD? Yes, we have the same RQD. So now here, do you have equal angles? Yes, we have equal angles. Why we have equal angles? Because angle, the inscribed angle QTD and the inscribed angle QUD have the same RQD. That is. So if we want to find it now here, we can say it that measure of angle 3 equals to measure of angle 4. So we have measure of angle 3 is a given here. Measure of angle 3 is 5x and measure of angle 4 is 2x plus 9. So we have to make them equal because we have 2 congruent angles. So 5x equals 2x plus 9 and we have to cancel x or collect x's to one side, and we said it before the holiday that if we need to solve it, we have to move the smaller term to the greatest term. We have to compare between 5x and 2x. So which is the smaller now? Yes, the smaller is 2x. Excellent students. So here 2x, we are going to move it to the second or the left side, becomes 5x minus 2x. Why minus? Because here we have 2 is what? Positive or negative? Yes, we have 2 is positive. We move it to the other side, becomes negative. So here 5x minus 2x equals 3x, and we have 9 as it is on the right side. And after that we are going to divide it by the coefficient of x, which is 3. So 3x divided by 3 and 9 divided by 3. So we can find that x equals 3. That is, thank you. And we studied before. Now here, example 6, GH is a diameter. Yes, GH is a diameter. What else? And the measure of angle GNH. GNH equals 4x minus 14. Okay, find the value of x. How could we find the value of x? We studied before. Teacher, we have here GH is a diameter. Yeah, and we studied that. If we have a diameter inside the circle, so we have what? I hear someone saying that we have right angle. Yes, we have right angles. Very excellent students. So here n equals 90. Angle n equals to 90 because it's drawn in a semicircle. And if you remember before the holiday, we take it, and some students asked me, teacher, what is the semicircle? The semicircle is a half of a circle, and it cut by a diameter. So GH is a diameter. So measure of angle G and H equals to 90 degrees. So here we can say that 4x minus 14 equals 90. And by solving, 14 is negative. Move it to the other side, it becomes 90 minus 14 equals what? Who can say it? Yes, you are an excellent student. And after that here we will divide it by 4. So x equals 26. So how could you find it? This is your homework in example 6. Solve the equation 4x minus 14 equals to 90. And how could you find it? X equals to 26. And I will see this homework after the holiday. Thank you. And here we have, if a right triangle is inscribed in a circle, then the hypotenuse is the diameter of the circle. Here we know it from the previous lesson. And now here we have example 7. We have an angle and we have a diameter GH, and we have a measure of angle 1 and measure of angle 2, and we will ask you to find the value of x. The same idea, but in another way. Here we have GH is what? GH here is what? GH is a diameter. So here we have G and H. The angle G and H is what? Is a right angle. Yes, so here we have a right angle. We said it before. So the measure of the interior angles of a triangle equals what? Equals 180. Excellent. Very good. So here, how could you find measure of angle 1 and measure of angle 2 now? Can we add all of them? Yeah, we can add all of them and make it equals 180. This is a solution. Or measure of angle 1 plus measure of angle 2 equals 90. So we are going to substitute measure of angle 1 now. Here is what? 6x minus 5 plus 2x minus 3x minus 4. Again, the measure of angle 1 equals 6x minus 5 plus measure of angle 2, 3x minus 4. Here we have it. 6x minus 5 plus 3x minus 4 equals to 90. And again, here you have another homework to solve it in your home. How could we find x equals to 11? The step of how could you solve a linear equation. Now, the same one, we can do it and find it for what we studied before. For example 6 here, we do it again and the same idea. You have it, okay? And thank you very much for your listening, my dear students, and see you in next lesson, and see you later. Thank you very much.
Thank you for listening to our explaining, and I hope that you enjoy our explaining now. And the homework, you can find it on the website using the Moodle program. Thank you very much.